Okay, good morning, fifth years. Sorry for the delay with this. I tried and failed miserably to complete a conference with you guys, but unfortunately it just didn't record and it didn't save for me properly. So I'm going to go back to our tried and tested way of explain everything and adding it up as a YouTube video instead. So I know the worksheet that I gave you over Easter was quite long, it was quite daunting, but I think it was really worthwhile in terms of all the content that it covered and how it helped you to revise, because it is the tricky questions like that they're going to ask you in the real thing. So question 1, the main compound of natural gas is methane. And question 2, the economic importance of oil refining. So oil as a product itself, when you drill it straight from the ground, it cannot be used, unfortunately. It's not of economic importance, but as soon as you start to separate it out into its various parts, petrol, diesel, oil, tar, loads of things like that, these are chemicals that we could not function on a daily basis without, and so all of a sudden it creates money, it creates jobs, and it is of massive economic importance. Question 3, methane is often found in gas fields at crude oil deposits. Crude oil is fractionated in order to obtain more useful products. Outline clearly how the fractionation process is carried out. So what happens is you get a fractioning column, and in that fractioning column the oil is heated to a really, really high degree, and it's pushed in from the bottom. The bottom is the really, really high temperatures, the top is the lower temperatures. It's heated to a point where it's nearly a vapour, and that vapour is then allowed to pass up through the various fractions, and depending on the temperature in each fraction is dependent on whether your product will come out. So the things with really, really high chains and really, really high boiling points, they're going to come off at the bottom of the fraction. And remember, when I say fraction, I'm just talking about a long column, a long tube. Whereas the lower chains, the smaller chains, the ones with lower boiling points, they come off at the top. In which fraction do crude oil, pentane and its isomers occur? So pent is carbon 5, and carbon 5 generally tends to come out in the second fraction, which is the petrol fraction. One use of refinery gas, it's used as domestic gases all around the world. Naphtha and gas oil are two of the hydrocarbon fractions obtained from the fractional distillation of crude oil. Explain how do the molecules of naphtha fraction differ from the molecules of the gas oil? Well, the naphtha fractions, they're generally in length carbon 7 to carbon 10, and they have a boiling point in a range of 75 to 150. Gas oil has a range of 220 degrees Celsius to 330 degrees Celsius, and their carbon chains are generally from C14 to C19. Question 10 is, crude oil is separated into a number of fractions in oil refining. The two fractions which contain molecules with the carbon chain lengths needed for petrol. So petrol is generally needed for carbon 5 or so. So it is generally found in the light gasoline and the naphtha range. Question 11, use for kerosene fraction obtained when crude oil is fractionated. Kerosene, for any of you who have oil heating at home, is used in domestic heating purposes. So the likes of having oil heating at home will be the use for kerosene. Question 12, two properties of compounds are responsible for them being found in the same fraction, so that they would have the same boiling point or the same condensing point, and they would also have the same, in and around the same relative molecular mass. So if you're talking about things being in the same fraction, they might have the same carbon chain length or the same hydrogens present, so they're going to have similar relative molecular masses. Question 13, an everyday use of refinery gas. It's used as a domestic gas. Question 14, mercaptans are added to natural gas to give it a smell. So natural gas can be quite dangerous. If it's not controlled and if it's not managed properly, it can actually poison people. That's why I see so many ads on TV for, if you smell gas, call this number. So they've added these things in. Now, I'm not sure if Friends is still a popular TV show, but have you ever seen that episode where Ross is trying to talk to the pizza delivery girl? He thinks that he can chat her up or whatever, and from there he starts to tell her how they add a gas smell into gas. Well, that's what he's talking about. He's talking about mercaptans. Generally they're sulfur compounds, and any of you who remember using sulfur and iron, you'll remember that sulfur is really, really smelly. Actually is one of the ingredients in rotten eggs, so you can imagine the smell. Question 15, auto-ignition in petrol engines. It's the premature ignition of petrol-air mixture. It can be quite explosive. And the octane number is the measure of a fuel to resist this auto-ignition, which can also be called knocking. 17, lead compounds were used in the past to increase the octane number of fuels. Lead compounds are unsuitable as they destroy the catalytic converter. Now, the catalytic converter in a car is something that takes bad gases and puts them into less harmful gases. And that being said, the less harmful gases, for example, would be carbon dioxide. Now, it's not that it's not harmful, but it's less harmful than, say, carbon monoxide, which can poison us straight away. They first thought lead was a great idea to add it into petrol. It would increase the octane number, make it a better fuel. But they've then discovered that it was actually really bad for the environment and it was destroying catalytic converters in your car. So that's why we have unleaded petrol. 3 structural features of hydrocarbons with high octane numbers. They have short chains, they are branched, and they generally have a cyclic structure. The table shows the octane number of 4 hydrocarbons. Hexane has the lowest, and what structural feature of the molecule contributes to this? Well, hexane it's long, it's a straight chain, and it has no branches. Whereas if we have a look at I know this is question 20, so cyclohexane, cyclo, the hint is there, it's a circle. Benzene is also a cyclic structure. And 2,2,4-trimethylpentane, it's a shorter structure and there's a lot of branching. Okay, 21. The 2 hydrocarbons used as references when establishing the octane number of a fuel are heptane and 2,2,4-trimethylpentane. You have to draw the structure of each of these. So heptane, 7 carbons, 1, 2, 3, 4, 5, 6. Just move it over a bit. 7, and then you're adding hydrogens on to each of those. 2,2,4-trimethylpentane, just as easy to draw. So when I'm drawing this one, I always start with the pent. So pent is 5. 1, 2, 3, 4, 5. Then I go to the 2,2,4. So 1, 2, there's carbon 2, but I have 2 2s, so that means I have 2 branches on carbon 2, and I have 1 branch on carbon 4. And then trimethyl, that tells me that each of the branches are methyl branches, and a methyl branch is one that contains 1 carbon, CH3. And wherever you have a blank left over now, you add in a hydrogen, making sure that each of your carbons have enough hydrogens. So remember, each carbon can only have 4 bonds, so be careful with carbon 2, it actually doesn't need any more hydrogens present. So you should end up with something that looks like this. These 2 hydrocarbons are really important reference hydrocarbons. Remember, 2,2,4-trimethylpentane, good fuel, high octane number, resists knocking really well, octane number of 100. Heptane, not so much. Really, really bad at resisting knocking, has an octane number of 0. Question 22, whether A or B has the higher octane number. B has the higher octane number, guys, because it is a shorter chain and it has a branch. Question 23, the isomers shown below would have the lowest octane number. Well, the lowest octane number here, in my opinion, guys, would be A. A is the longest chain and it has no branching and it has the highest number of carbons in a straight chain. So A would have the lowest octane number. To flip that over, C would probably have the highest octane number present because it is a shorter chain and there's a high degree of branching. Okay, 24. Dehydrate cyclisation is one of the processes used to increase the octane number of hydrocarbons. 2 changes to the hydrocarbon molecules occur in this process. So dehydrate cyclisation, when straight chain alkanes are converted into cycloalkanes, and those cycloalkanes are converted into aromatic compounds. Question 25. 2 reasons why oxygenates are added to petrol. They're added to petrol to increase the octane number and to help reduce pollution. 27. 2 other ways other than the addition of lead that the octane rating of a fuel can be increased. You can have catalytic cracking or you can have dehydrate cyclisation. Sorry, skip to number 26. Name 3 oxygenates. You have ethanol, methanol, or you have a really important one that you really need to remember, which is MTBE. You don't need to know what it stands for, but you need to know that it helps to increase the octane number of a fuel. Number 28, the process carried out in an oil refinery that converts hexane to compounds such as cyclohexane and benzene, that is dehydrocyclisation. Question 29, 2 reasons why oxygenates such as MTBE are added to petrol. It's very similar to question 25. It's to increase the octane number, and it is to reduce pollution. Number 30, to explain the term isomerization, where you take a long straight chain hydrocarbon which has a really, really low octane number and you convert it to their isomers. So basically you chop bits off and you stick them back on at different angles. You create a shorter chain with lots of branches, so you're increasing the octane number. Question 31, catalytic cracking. You're breaking long chain hydrocarbon molecules by heat and using a catalyst, and you break them into shorter chain molecules. 32, explain why some of the kerosene produced in oil refining is subjected to catalytic cracking. The kerosene chains can be quite long, and as demand for heating oil decreases, the demand for, say, the likes of petrol might increase, or the demand for refinery gas. So by decreasing the length of the carbon chain, it can be used for more effective fuel. Remember, the whole reason of catalytic cracking is you want to drive up that octane number, and if you drive up that octane number, you're going to increase its efficiency as a fuel. Question 33, straight chain molecules. So C13H28 underwent catalytic cracking. You had C2H4, C4H8 molecule left over. Now, with this, what I would do is I would add those two together. So sorry for making this a little bit smaller, but I just want to show you what I would do. I would add my C2. So I have C2H4, and I'd add my C4H8 together. So I'd be left with C6H12. And then I take that away from the original molecule, which is C13H28. So when I take those away from each other, I'm left with C7. This should be, sorry, the hydrogen there should be 12. You're left with C7H16, and that happens to be heptane. Now, heptane was one of our reference hydrocarbons, this guy up there, and it has an octane number of 0. And final question then, why is the use of benzene in petrol strictly controlled? Because benzene and associated compounds such as methylbenzene have been proven to be carcinogenic, so that means they are cancer-causing agents. Okay, I hope this helps, and homework tonight is to just submit corrections of your worksheets. Thanks, guys.